Hello, here in Pablo Spot, I'm George. Welcome to this special episode where I revisit my Elastic Beanstalk infrastructure for upgrades and specific implementations. So let's get into it. This episode is courtesy of Akshay Saini, who asked how Elastic Beanstalk can be configured with custom VPC infrastructure with pre-built configuration that is similar to a user data for EC2 instances. When I was reading his comments, I thought this seems impossible to implement given that Elastic Beanstalk is more or less an AWS managed service. Moreover, my experience with Elastic Beanstalk tells me that most of the option settings are limited and controlled. I was going to suggest moving from Elastic Beanstalk to ECS infrastructure, but then again, Elastic Beanstalk is a very good complementary infrastructure solution for implementing MVP or most viable product. So, what can I do about this? When Elastic Beanstalk was updated to support Amazon Linux 2, the concept of platform hooks was also introduced. So this is what I'm going to explore. And like I mentioned earlier, I also need to make adjustments to my infrastructure to accommodate for non-default and custom VPC infrastructure. So I have a number of option settings that I need to change on my infrastructure. So I'll start opening my main.tf inside my infrastructure directory, and then head to my Elastic Beanstalk environment resource. The first setting that I will add is the VPC namespace, which I will define if a VPC ID is provided. And because I added a new variable in here, I need to have this defined inside my variables.tf. And then I'm going to set a default value for this variable. And now back to my main.tf. The next setting that I need to add is for my private subnets. I'm also making this setting dynamic such that if there are private subnets that are provided, then I'm going to create that option setting. And because I have a new variable in here, I'll go ahead and define this inside my variables.tf. I'm going to set the type of this variable to list and set a default value of an empty list. Now back to my main.tf. The value property of this setting expects a string. So I will convert my new private subnets list into a comma delimited string using the join function. I also need to add new settings for my load balancer subnets. So I'm going to duplicate the private subnet block that I've just created and change the name of the setting accordingly. And then I also have to go to my variables.tf to define this new variable. And now back to my main.tf. The next option setting that I would like to use is the custom security group that is created inside my VPC. So I will add a new setting block that will consume this custom security group. Like all the previous settings that I've just added, I'm going to add this setting if the instance security group variable is provided. And so I'm going to go to my variables.tf and define this. And now back to my main.tf. I will also update the load balancer security groups to use a custom version. Now I'm going to head to my variables.tf to define this new variable. Now back to my main.tf. It's been a while since I've stood up this infrastructure, and AWS has released several versions of Solution Stack for Docker since. So I need to update my environment resource to use this new version. On this resource, I'm going to update the Solution Stack name property to use the latest version, which is 3.4.17. The next set of changes I will implement are relevant to how I could inject user data properties on my EC2 instances inside my Elastic Beanstalk infrastructure. What I want to do is enable my SSM agent on my EC2 instance upon startup, and also be able to inject a CloudWatch configuration to extract some metrics out of my EC2 instances. So on my current setup, my application source bundle contains one file, and that is my Docker Compose file. And this is the relevant resource block that creates that file. What I need to do is generate an application source bundle that contains not just my Docker Compose file, but also some platform-related hooks that will eventually be loaded and run inside my EC2 instances upon startup. To start creating this new resource bundle, I will change the file name property on this resource to dump the file to a particular directory. So on the file name property, so now instead of generating the Docker Compose file in the root of my repository, this file will be created inside a new directory called ebsource. So let's go ahead and create that directory in the root of my repository. Inside this directory, I will also create a directory structure that represents platform hooks. I can then create my custom script inside this new directory structure. When Elastic Beanstalk starts the environment and completes the download of the application source bundle, it will execute any shell script that it finds inside that platform hooks prebuild. And so I'm going to go ahead and write the contents of my custom script. And I'll be running this as a bash script. The first thing I will do inside this custom script is enable and start SSM agent, which will allow me to connect to my Elastic Beanstalk EC2 instances using SSM. The next step that I will run inside this script is install my CloudWatch agent. And then this next step is where I'm going to inject a custom CloudWatch configuration file to extract some custom metrics for my autoscaling group resource. What I've essentially done here is create a here.doc content and dump it into a config file. Inside this here.doc content is a $sign. And I need to make sure that I escape the $sign to keep the character intact. And the last step inside my custom script will be a command that will instruct CloudWatch agent to consume the config.json file that I've just created. And that is all I need to run inside this custom shell script. If I need to create other scripts that I want to run to extend the capability of my EC2 instances, I can just create as much script as I wish inside the prebuild directory. To ensure that both my CloudWatch and SSM agents are going to work properly, I also need to grant the right permissions to the instance profile that I associate with my EC2 instance. So on my main.tf, I am going to update my IAM role resource. On the manage policy ARNs property, I'm going to add two new AWS manage policies. The first policy contains all the necessary permissions that will allow metrics to be extracted from each EC2 instance in my Elastic Beanstalk infrastructure and feed that into CloudWatch. And then the second one contains the relevant permissions to enable access to EC2 instances via SSM. And because I have now changed the location of my application source bundle, I need to update the data reference that creates the archive file. So let me go ahead and open my data.tf. And instead of using source file property, I will change this to source dir and point this to my new EB source directory. And to make sure this archive file gets created after my Docker compose file is created, I need to add depends_on property and then set the dependency on my Docker run config resource block. Next thing I need to do is update my tf-vars file for the new set of variables to accommodate the custom VPC infrastructure elements. The first variable that I need to define is my VPC ID. And then my instance subnets, my load balancer subnets, my instance security groups, and lastly, my load balancer security groups. And now that that's all set, let me head to my VS Code terminal and stand up my infrastructure. My infrastructure has been stood up successfully. Now let me head to my browser and then access my AWS Web Console. The first thing I will do to verify that my pre-built config changes work is to head to my EC2 page, go to my EC2 instances, select my Elastic Beanstalk EC2 instance, and click Connect. The Session Manager tab on this page loads properly and the Connect button is enabled. So let me connect to my EC2 instance. That worked. Now let me proceed with this session and then run a command to check the status of my CloudWatch agent. That also worked. And if I head to the logs directory for my CloudWatch agent to verify that the custom configuration file has been read and loaded, this section of the log tells me that my config file was loaded successfully. And if I check the contents of my configuration file that was loaded using my pre-built hook, the file is there. And all that's left now is to verify if the endpoint is loading successfully. And that also worked. And that's all I have for today. Let me know your thoughts in the comments below and send me some likes if you find this useful. And don't forget to hit the subscribe button if you like the content on this channel. Until next time, keep learning and stay safe. See ya.